Hello everyone. So I welcome you again in this lecture, and today we are going to talk about load balancers. Already we have discussed load balancing concept in Amazon, that is in AWS. Today we are going to talk about the concept of internal load balancers in Microsoft Azure. So what is this service? This is a very important services in the cloud computing. So here it is a kind of service which basically distributes all the workload among the resources which are into the cloud. What does it mean? Let us take an analogy. There is one company, and the company is expecting a lot of queries that comes to the company. So the what the company does, company has a reception that basically takes all the customer queries. So the company actually employs 4 person, and they sits at the reception to handle all the queries. Now assume that 20 queries are coming at any point of time, and if all the queries are handled by 1 person, then what is the impact? The impact is that only 1 person is handling the queries, the three others are not using it. That means we are not optimally utilizing these person, and also the time required to answer all the queries will be more because only 1 person is engaged to take care of all the queries. What is the good way of handling this? The good way is, if 20% are there, then we can do a rough mathematics that 5% to be taken care by by each employee which are sitting at the reception. So the impact of this is that now the query time will be minimum, and we have optimally utilized all the resources, means all the employees which are hired by the company. The same thing we see, there's a company who is having the application. So the company deployed the application servers which runs the application. Let's say there are 10 application servers which runs the company's application, and a lot of traffics are coming onto the servers. So there is a load balancer which basically take all the traffic and distribute these requests which are coming from the customer to the server, so that every server is equally engaged. So the overall impact is the query time will be minimized, and also the resources will be fully utilized. So we have two kind of load balancers. One is internal load balancer and the public load balancer in case of Microsoft Azure. As the name suggests, internal load balancer, this is basically balancing the load that for all the requests that comes within the cloud network. So if all the resources which are onto the cloud, then these load balancers are going to take the request from the resource inside the cloud and distribute within the cloud. It will not take any request from outside. That is done by the public load balancer, where the customer may be using browser, and they can try to access any of the resources. Then it goes to the load balancer. Load balancer will then handle it and decides to which particular server that request must be forwarded. But in internal load balancers, the request must be coming in from the inside resource, inside this network onto the cloud. So in other sense, you can say that in the internal load balancer, we have a private IP given to us. That means this IP cannot be accessed by the outside world, okay, or outside the virtual network. Already we have discussed in our theory session that load balancer is a kind of point of contact for all the queries. So whenever any queries come from the customer, does not directly go to the application server, but it goes to the load balancer, and then load balancer will decide or distribute. So there are multiple algorithms maybe working that guides that how the distribution to be done. By default, we can say like a round robin is also one of the strategy which is used by doing this load balancing. What does it mean round robin? Means if there are two virtual machines are there, and if any query comes to access these virtual machine, then the first query must be directed to virtual machine 1, then second to virtual machine 2, third virtual machine 1, and then 2 and 1 and 2. So in this way, this is called round robin. This is a default you can understand, but there may be multiple ways to decide that how we are going to distribute the workload. So let's see all these things in our uh, practical. So let's start. Okay, so this is my console screen of Microsoft Azure. This is a workspace where we are going to do all our kind of practical. So in our demonstration, we are going to provision three virtual machines, and the two machines will be acting as an application server and one machine will be acting as a test server. So from test server, we are going to send a request that goes to the load balancer, and then load balancer will then distribute this request to these application servers. So what we do, we will deploy, or we can, you can say, we can provision one application server as a window machine and one as a Ubuntu machine, so that we can easily see in our output that the request goes from one machine to other machine in a round robin fashion. Okay, so we'll start creating our virtual machine. Some points we need to keep in mind that because we are demonstrating the internal load balancer, so the request must be sent from inside the network. So what we are going to do is we are going to create all our virtual machine inside one network. This is the only thing we have to keep in mind, and other things we just keep as default. So we'll go to the virtual machines. We'll go for virtual machines, and then we create. So let me create first window machine. We know that all the resources that we provision in the Azure cloud must be inside one resource group. So you can take any resource group which is existing, or you can create one resource group. In the same resource group, we are going to keep all our resources. So let's say this is demo load balancer resource group. So we are keeping inside this resource group all our resources. Then virtual machine name, let's say virtual machine one, which is window machine. You can give any name, window application server. We can just make it shorter. We can say window is, and we are deploying this in this region, and then we keep all the things in one in one place just to demonstrate this internal load balancing. So for this, we can create one availability set. Inside the set, we keep all the things. So we can create one set here. Let's say it is uh, okay. I'll choose from here. You can just either type it, or let's say this is set one, and click on OK. And this is going to be a window server. So I'll select the image. The image is same like AMI that we were using in the AWS. So here we are using window image. That is, and now this image is going to configure for us this configuration: one virtual CPU with 3.5 gigabits of memory. Okay, standard. And then we will go for this credential, username and password, which is required to uh, connect to your virtual machine. So you can give any name. Okay, let me choose this. Let's say demo user. I'll give some a password. It can be any password. And then this is RDP is to be used. It is for remotely connecting your window machine. This is to be used, and also we want to connect our virtual machine through a browser using HTTP. So we'll also select this. So inbound basically, defines that what kind of traffic can enter to your network. Okay, then we will go to the next part. So we know that in order to provision any virtual machine, we have to undergo these 7 stages. And we already discussed in our previous video that what is to be configured or set in these seven options. Here we are just keeping all the things default. We just take care of networking, that we want to keep all the resources inside one virtual network. So let us create one virtual network. Let's say either you can create a new or you can take existing one, and but you need to keep in mind that whatever the network you are choosing, you have to keep everything inside that network. Okay, so let me take a new network. So create new. I will write it as demo network for load balancing. Click on OK. So demo network LB, we are keeping everything in this inside this, and other things we keep as it is. And okay, so I think we are done, and we can just click on review and create. So it will do some validation testing, and once everything's got validated, we are ready to create our virtual machine. So validation passed. We click on create, and it will create the first virtual machine for us. So here you can see it is saying deployment is in progress. So it will take some time to get it completely configured for us. So you can see this is deployment is complete. We can go for our second virtual machine. So let's go to, okay, let's go to the virtual machine. Here you can see here. So we'll go to create virtual machine. We will be in the this demo load balancer RG, and then virtual machine name is, this is virtual machine 2, and this is again we are going to create a window machine, and the purpose of this machine is as a test server. You can give any name, and then it will be in the same region, and we will keeping in the same availability set, which is set 1, and then we keep it standard, and we are going to create window machine, so we'll keep everything default. And okay, so with this default we get this configuration. Username we will give here, let's say demo user. You can give any password. This is to be used while connecting our virtual machine remotely, so this can be used as a credential. And here also we are going to do connection remotely, and also we want to connect through the browser using HTTP. And the other thing is remaining is we have to set the resources in the same network. So we'll go to the networking part, and we select, so this is our network, it's already chosen here. So rest thing is okay. We will go to the, we go and click on review and create. So now we are done with creating two virtual machine. Out of these two virtual machine, which one is actually acting as an application server, one is acting as a test server. So validation has been passed, you can see here, and you can click on create. So we are done with the two virtual machines. Now one more machine is remaining. So the third one is again an application server, and it is Ubuntu machine. Okay, so now we can, while it is in the progress, we can go and create our third virtual machine. You can go to here, and you can click on create, go to Azure virtual machine, and here we will be in the same group. This is our virtual machine 3, and this is our Ubuntu machine, which is also acting as an application server. Okay, reason is same, and then we keep in the same set, which is set 1, and we keep the security as a standard. And here we take the Ubuntu image, So this Ubuntu image will give this configuration, which is the default configuration here. So we keep all the things as it is. And for connection, okay, let us give some, let's say, Azure user. You can give any password here. And then to connect our this Linux machine or Ubuntu machine, we are connecting with to the SSH. To window machine, we use RDP. So here I am also allowing the connection using this HTTP. So I am just permitting two protocols here, SSH and HTTP for the connection. And the other thing left is the networking. So in the networking part, we go and select. It's already selected by default. So now we are done with the three machines in the same network. So click and create. So it says something is missing here. So we have to check what we have missed. So we have to go to this part and see what we have missed here. So this is all done. This is all done. This is all done. Okay, we are so here it appears like we have done all the things. Let's go to and check what is left in the networking part. So we have chosen this is okay, okay. This is okay. Okay, this is not required here. We can just remove it and then we click and create. So let's see uh, is passes the validation or not. If it is not, so if it is not, then we have to go and cross check what is missing. So in our case, so we are done with creating all the three machines. Now what is left? We are done with the three virtual machines. Now we are going to create one load balancer. So we'll go and search for load balancer here. So this is load balancer. You can type it here or you can find it here. Okay. So you go to load balancer and then we have to create a load balancer. So you can go and create load balancer here. And this must be in the same resource group. This is the same resource group and you can name here. Let's say this is demo load balancer or this is demo internal load balancer. The reason is same and we keep standard. The type is internal. So in the other video, we will also demonstrate how to create a public load balancer. This is for internal load balancer. Okay. Then we have to set the front end IP configuration. Okay. So click on it. So here we have to add a front end IP configuration. Go and click here. And we have to give here some name here. Let's say this is a demo load balancer front end. You can give any name. Okay. And then virtual network is demo network load balancer. This is what we have chosen. And subnet is this one. Okay. We are done with all. Click on save. Then next we have to create a backend pool. So backend pool is basically a pool of resources which are to be taken care by the load balancer. So we will click on add a backend pool. So you can name here uh, demo load balancer backend. Cool. This is done. And after that, click on to add. And here we have to choose the virtual machines which are to be taken care by the load balancer. So we have to select those virtual machines which we are calling as a application server. So here you can see these are the machines which we have, and this is also an application server. This is a test server. So we'll choose this two machine inside the pool. Click on add, and then I guess we are done with this. And just click on save. And then let's look onto the inbound rules. Uh, the rule. So we'll go and click on add a load balancing rule. So let's say uh, demo rule one, demo load balancing rule one. Okay, so front end IP address is whatever we have chosen, demo front end, this we have to choose. Backend, we have given a name, demo LB backend pool. Okay, and then we'll keep the things as it is. Here we have to keep port number 80. Backend port is also 80. And what about the health probe? So health probe, we have to give some. So far we have not created any probe. Let us create a new one. We can just name here demo LB health probe. Okay, and protocol is TCP port 80 is okay, interval 5 seconds. So basically, health probe basically defines that your instance is healthy or not, means the resources which are inside the pool on which the load balancer is working is healthy or not. What does it mean? So let's say there are three instances working in a pool, and then the load balancer has to distribute the incoming request among these three instances. So before the load balancer passes these request to these instances, it will first check that the instance is healthy or not, it is running properly or not. So how it will check? It will first do some very initial communication. It will send some request and expect some response from these instances. So here we are keeping that in the first 5 seconds it will do some communication, and if it is getting a proper response within this time, then it is assumed to be a healthy instance. Otherwise, the load balancer will assume that the instance is not healthy, and it will not consider that instance for distribution. This is meaning of health kind of the status of healthness for the any instances. Okay, save here. So we will keep the other things as it is and click on save. Okay, so we are done with the inbound rule. All things are done here. We click on the outbound rule. So here there is nothing to do here at this point of time. Tag is also nothing to do here. We'll just go to review and create. So this is the thing that we are going to use for our connection front end. IP connection is demo LB front end. Now this will be act as a connecting point, a POC, a point of contact for any request. So we'll click on create. So we are done with the almost we are done. It's showing deployment is in progress. So we are done with creating three virtual machine. We are done with creating one load balancer, which is internal load balancer. Now we need to. So if you look to the virtual machine, if you want to access using HTTP, so let's go to the virtual machine. I want to demonstrate you something. So we have this virtual machine. So if you go here, it has a public IP. This is having a public IP here. So you can just copy this, and if you want to access this machine here, it is not going to show you anything because there is nothing installed here. Okay, so means there is no server running on it. So what we are going to do is we are going to install a server onto this machine, and also we are going to install a server onto Ubuntu machine one by one. So let us first go to this machine. So how to connect to this machine? We have to use RDP here. So okay, so we have copy this. I am talking about this window application server. I'll copy this, and I'll go to connect, and then you will download the RDP. This is used for connection. Okay, it is here, and then I'll just click connect, and I will write the password here. This is the password that we have set at the time of creating this machine. So you can see we are actually able to connect to our virtual machine remotely using an RDP. So this is done. Okay. Now what next? The next is where this is okay. We'll just minimize it. Now we will try to connect to our this machine, which is Ubuntu machine. So we'll go here, and then uh, this is public address of this Ubuntu machine. Okay, so you can just copy this, and then we will connect using SSH. So we'll just go to the command prompt, and then you will write here SSH, and then you will write the user. So the username is, and then you write at the rate, and then write the public IP. It will ask the password, so give the password which you set. Okay, so we are done. We are able to connect to our Ubuntu machine. You can see this written here, Ubuntu app server, which is the name of a machine. So you can just write here clear, so we can get a new screen. Okay. Now if you look here, if you we already have given the inbound rule as HTTP. We have set SSH and HTTP. That means we are allowed to access the machine using a browser through HTTP. So if we use this IP, and if we want to connect to a machine, so it will not show you anything because this machine is nothing to show at this point of time. Okay, so what we will do, we will install a server onto it, and that has a default page. So whenever you want to connect using HTTP, it will show you the default page. So let us first go to our this Ubuntu machine here. Just a minute. You can see here, this is our machine that we have connected. So let us install here Apache Server 3. So we write here, first we will just configure it properly. We will update this machine. So we will write sudo apt get update. Okay, so we are done with this, and then we install Apache Server onto it. So we'll write here sudo apt get install. Oh, we have written the wrong command. Let me correct it. It should be sudo. Okay, so I believe this is okay. Okay, so we are done with this installation. Now, if you look to it, this is the public IP of this Ubuntu machine. This is the same. So if I go here and if I refresh, we expect to get the this index page that we have just installed. Okay, but what about this? We are not able to get it. So let us also install a server onto this window machine. Okay, so we'll go to our, mm, let me quickly look to that. This is our machine. Okay, so we'll uh, try to install into it IAS server. Fine. So we'll go here. Before that, you can just have a check that this is the machine that we have created or it is something else. So here you can see this is the VM1 window application server, and this is the ID. This is a public IP. You can just cross check. This is the public IP which we have actually, which is assigned to our virtual machine. Okay, so now you can go here and go to this add roles and feature. Okay, and then we will then we go to next. Then we go to the next role based feature based installation must be selected. And then okay, we are just keeping all the things default. Go to next, and here we have to select uh, this web server IIS, and then you can click on add features, and then just click on next, and it will start the installation. So again next and next. So let's just cross check what else is remaining. So all thing is actually done. We have to click on next and click on install. So you can see it start installing, and once it is installed onto this machine, we can see that uh, page from our HTTP, means from the browser also we can access it. So what we have done so far, we have made two virtual machine as an application server, which actually runs our application. So one is a Ubuntu machine, one is our window machine, and on all both the machine we have installed uh, a server on one which is Apache server and the other is on IIS server. Okay, so once it is getting installed, we can just verify it that are we able to see the index page from the HTTP request or not. So we have to wait for some time. So it is saying that installation succeeded on virtual machine 1 window AS, which we mean window application server. So now let us go back to this browser and let us refresh and see what is happening here. And we can see that now that web page is visible to us. So if you go to this part, this is visible, and if you go here, this is visible. Now why we have used two different operating system? Because if we have used the same window machine, then the default web page appears like same. So either we have to change the web page in order to differentiate. This is one way, or you can check the IP also, that is also the one way. But as a higher level view, on in terms of like how it appears like, so this you can easily distinguish that this is one server and this is other server. Okay, that's why we have used two different machine. Now what is remaining? We have to go to our test server, and from the test server we are trying to access these machine, and we will see that every time when we try to access, this is a round robin kind of behavior is visible, because the load balancer is equally and distributing the request to both the servers kind of equally. Mean the first request will go to the Windows server, the second goes to the Ubuntu server, then third goes to Windows server, and so on. So we'll go back to our this console, Azure console, and here you can go to virtual machines, and then we will try to connect to our test server. This is our test server. So how to connect? We are going to connect using RDP. So to connect with the RDP, we need to have a public IP with us. So this is our public IP address. Then we go to connect. We use this download RDP file, and then you can use this file to connect. So you have to write the password here. So you can see the public IP of this machine is 52.184.68.162. 52.184.68.162. We are able to connect to our test server. It will take some time to configure it properly. Now let me remind that how the entire system will work. All the requests which are sent, it goes to the load balancer, and the point of contact for the load balancer is the front end IP. Means we have seen that there is something called front end, right? That front end is become the point of contact. So when this server test server send any request to access our application server, then we have to so the request will go to the front end, and then that is actually a load balancer, and that load balancer is then distribute or forward the request to our instances which are application servers. Okay, so okay, then just cancel this, and then we need to send a request from here. We need to know what is the front end IP. Okay, means the uh, front end part, that is a kind of connection part from the load balancer. So we'll go back to our so let us minimize this for a moment, and we have to go back here, and we go to the load balancer, and in the load balancer we have to check what is the front end IP configuration, right? This is what we need. So this is 10.1.0.7, and you can also notice here that this front end IP configuration is a private IP address. That means it is only allowed to be accessed inside the network, because private IPs are not accessible from outside the network. Okay, so for that the public IP is required. So this is also means you can relate that this is something called internal load balancing. So we'll just copy this 10.1.0.7, and we go to our this one. This is your test server. You can see this is written as test server. Okay, and then you can we can so let us find the Internet Explorer. So you can write here Internet Explorer. Okay, this is here. So now we are in the test server machine, and this is Explorer. So if we write here that front end IP, this is 10.1.0.7, and if we want to just we will want to see what is happening. So you can see when we send a request, it goes to our Ubuntu machine, and if I refresh this, it is actually showing you the window machine. That means now the load balancing is working. This is what the load balancing means. It is distributing all the requests to all the instances which are available there. Means among the pool. So here, when we say pool, so here we have a pool of two instances, the two virtual machine that is actually there to take all the requests. Okay, so this is how it works, and I think we are done with this exercise and you have understood. So let me quickly recall what we have done so far. We created the three virtual machine. Two virtual machines are acting as an application server, which are to be handled by the load balancer, and then we created one virtual machine which is acting as test server. So we you make a request through the test server that goes to the load balancer. Load balancer will then forward the request to a set of instances which are inside backend pool. Okay, so this is how the entire thing works, and so we are done with our objective, that is to demonstrate the internal load balancer. We will next we will see that how to demonstrate the public load balancer. So this is all for this video. Thank you very much.